we'll explore the Anthropocene, the proposed geological epoch in which human activities leave a measurable imprint on Earth's systems. Why do markers matter? Because they are the tangible evidence of our far-reaching influence, recorded in sediments, ice cores, and the built environment. The Anthropocene is the proposed epoch where human activity leaves a measurable imprint on Earth. Why do markers matter? They're tangible evidence, written in sediments, ice cores, and the built environment. Today, we'll look at two kinds of markers: chemical signals and novel materials. Chemical markers include disrupted biogeochemical cycles and the global datable signature of radioactive fallout. Novel materials include technofossils like microplastics and concrete, distinct layers future geologists will read as unmistakably human. Clues: chemical signals and novel materials. Evidence recorded in sediments, ice cores, and the built environment, and reflected in everyday campus operations. Laboratories classify wastes by characteristic, like ignitable, corrosive, reactive, toxic, and by EPA-listed categories, with clearly labeled satellite accumulation areas. Empty containers and contaminated materials follow special rules. For example, batteries, electronics are collected separately. Environmental health and safety oversees labeling, storage, pickup, and compliance, ensuring no hazardous or radioactive materials enter regular trash streams. Closed chemical cycles mean turning input-use-output into loops that minimize pollution and waste. Yukon operationalizes this through purchasing that favors low-emission, recyclable or biodegradable materials, expanded composting of food and biodegradable serviceware, and metering and reuse across water and energy systems. Strict segregation, recycling, composting, and reduction policies are the day-to-day expression of chemical closure. Microplastics arise from the fragmentation of larger plastics and now pervade waters, sediments, and biota. On campus, they're most visible in single-use items: fast food packaging, Dunkin' straws, bottled drinks. Yukon actively reduces this load. The dairy bar uses paper products. Dining relies on biodegradable paper boxes. These choices, paired with recycling and composting, cut plastic leakage to local soils and waterways. Concrete is a defining techno-fossil. Most post-2000 Yukon buildings, academic halls, residences, bridges, are concrete, writing a human-made stratigraphic horizon of aggregate, cement, and rebar. Because cement manufacturing is carbon-intensive, Yukon aims to balance growth with higher building standards, targeting LEED gold, efficient systems, and renewable energy integration to lower construction's climate footprint. By coupling rigorous hazardous waste management with material reduction and circular practices, Yukon not only reads the Anthropocene's chemical and material signals, it actively shrinks its campus impact, modeling a cleaner, lower carbon path forward. Opening in the Anthropocene, our materials are leaving signatures that future scientists can literally dig up. Today, I'll focus on two: microplastics, the most pervasive trace of throwaway culture, and concrete, the backbone of modern infrastructure and a major climate driver. What they are and why they matter. Microplastics are plastic particles under 5 millimeters. They come from primary sources like microbeads and, more often, secondary breakdown of larger plastics by sunlight, weathering, and mechanical abrasion. Reviews in 2022 show they persist for decades to centuries, adsorb toxic pollutants, move through water, sediments, and food webs, and can induce oxidative stress, immune and endocrine disruption in organisms. In short, they're a global waste management and health challenge. The Anthropocene marker. Because these particles are now found almost everywhere, from beaches to deep sediments and across trophic levels, they are a recognizable material fingerprint of our era. In Yukon Campus Evidence and Responses, Single-Use Reduction. In January 2019, Yukon Dining Services ended the use of plastic bags at retail and grab-and-go locations, replacing them with recyclable paper bags and selling reusables. In collaboration with Yukon PIRG's Zero Waste campaign, the goal wasn't to swap plastic for paper, it was to normalize bringing your own bag. Previously, dining used about 385,000 plastic bags per year. Eliminating them directly lowers the flow of plastic film that often escapes recycling streams and fragments into microplastics. For hydration over bottles, UConn's Office of Sustainability has promoted hydration stations to displace single-use plastic water bottles, noting that producing, transporting, and disposing of bottled water carries significant energy, emissions, and plastic waste compared with refilling. For recycling realities, UConn uses single-stream recycling for common materials: paper, cardboard, metals, glass, mixed plastics, while directing problem plastics elsewhere. Campus guidance emphasizes that thin films, plastic bags, shrink wrap, bubble mailers, and straws are not recyclable in the local system because they jam sorting equipment or contaminate bales. Clear signage, proper rinsing, and designated e-waste and battery drop-offs help keep contamination low and recyclables marketable. For takeaway, these operational choices, bag bans, refill culture, and correct recycling translate the big idea of closed chemical cycles into daily habits that prevent plastic leakage and downstream microplastic formation. Why it's an Anthropocene marker? Concrete is the most used human-made material on Earth, second only to water in total consumption. It literally writes a technofossil layer of cement paste, aggregate, and rebar into our landscapes. Multiple assessments place cement's embodied carbon around 0.82 to 0.83 kilograms. Carbon dioxide equivalent per kg of cement. With additional emissions from aggregate processing, admixtures, transportation, and construction activities. The sector also consumes vast quantities of raw materials and freshwater and generates demolition waste. Globally, demand is projected to remain high through mid-century, so decarbonizing concrete is essential to net zero trajectories. UConn campus context. Across campus, especially in post-millennial construction, concrete is ubiquitous. Academic buildings, residence halls, bridges, because of its structural performance and durability. In other words, it's the material expression of growth we can see and touch every day. Pathways to lower impact concrete. Industry advances now include substituting a portion of cement with supplementary cementitious materials like fly ash, slag, and silica fume, optimizing mixed designs, improving curing and construction logistics, using alternative fuels in kilns, and integrating performance-based specifications. Pairing these strategies with campus-level standards, high-efficiency buildings, LEED targets, metering, and renewable energy integration helps balance the benefits of concrete infrastructure with the imperative to cut embodied and operational carbon. Microplastics in concrete are two faces of the Anthropocene, one dispersed and invisible, the other monumental and everywhere. On campus, we see both. Plastic in our daily choices and concrete in our built environment. By eliminating single-use plastics where feasible, embracing refill culture, recycling correctly, and demanding low-carbon concrete and high performance in buildings, UConn turns global problems into local progress and leaves a lighter, smarter material footprint for the future. The Anthropocene challenges us to turn signals into action. At UConn, we can translate chemical stewardship and material choices into daily practices that measurably cut risk, waste, and carbon, while aligning with global sustainable development goals, chemistry, safer cycles, and transparent risk. First, strengthen hazardous waste management. UConn's EH&S already classifies laboratory wastes by EPA characteristics: ignitable, corrosive, reactive, toxic, and listed codes, with satellite accumulation area rules, labeling, and centralized pickup. Expand real-time compliance. It requires digital labels and inventory for every SAA, with QR codes that track container contents, open date, and pickup requests, reducing mislabeling and aging containers. Third, eliminate unknowns. Mandate pre-disposal characterization via standard methods and require witness neutralization only under SOPs, minimizing reactive or incompatible storage. Fourth, close loops. Adopt closed chemical cycles thinking. Source fewer hazardous reagents by default. Prioritize green chemistry alternatives and pilot reclaim programs. Solvent distillation, acid-base neutralization to reduce virgin purchases and emissions from transport. Nuclear-related research. Safety and transparency. If campus activities use sealed sources or radioisotopes, commit to 3-part. First, Publish an annual radioactive footprint summary, zero releases goal, inventory, training levels, and incident reporting, mirroring Anthropocene fallout awareness but demonstrating robust containment. Second, enhance training frequency and drills, and include public-facing explanations of dose, pathways, and controls to build trust. Transparency turns a potential Anthropocene marker into a model of risk minimization. Third, connect to SDGs. These steps advance SDG 3, good health, DG 6, clean water, SDG 12, responsible consumption and production, and SDG 13, climate action, by preventing toxic releases, reducing resource use, and cutting emissions in chemical life cycles, novel materials, cut plastics, decarbonize concrete. Reduce campus plastic use. Focus on microplastics prevention. Yukon Dining ended plastic bags in 2019, switching to recyclable paper and encouraging reusables with Yukon Perg. Hydration stations promote refilling over single-use water bottles. To accelerate. First, make bring your own the default. Offer discounts for reusable bottles and bags. Set opt-in for any disposable item at checkout. Second, target high-leakage items. Phase down thin films, straws, lids, and bubble mailers that jam local recycling. Provide clear signage and consolidated collection for alternatives. Third, improve recycling quality. Reinforce single-stream guidance, rinse containers, keep liquids out, and route e-waste, batteries, and construction materials to designated drop-offs to avoid contamination and microplastic generation from escape films. Encourage green building and low-carbon concrete. Concrete is ubiquitous on post-millennial Yukon buildings. Our visible technofossil. Pair that reality with lower carbon choices. First, specify mixes with supplementary cementitious materials like fly ash, slag, silica fume to cut Portland's cement content. Adopt performance-based specs to avoid over-design. Second, require LEE to gold or better and metered verification for new buildings. Include embodied carbon targets and procurement of lower carbon cement where available. Third, optimize logistics and durability, efficient curing, reduced waste, designed for deconstruction, to limit material throughput and demolition impacts. In the Anthropocene, the best signal is a shrinking footprint. By tightening chemical governance, being transparent about radiological safety, eliminating single-use plastics at the source, and demanding low-carbon concrete and high-performance buildings, Yukon aligns everyday operations with SDGs and turns our campus into a living lab for safer cycles and smarter materials. If the Anthropocene is written in matter, Yukon can choose what the next layer says. We've seen how chemical signals and novel materials, fallout, microplastics, and concrete become the markers of our time. The lesson is clear. Markers show us exactly where to act. In chemistry, we tighten the cycle, precise labeling and segregation in every lab, digital traceability for every container, green chemistry substitutions, and transparent radiological stewardship. In materials, we design out single-use plastics, default to refill and reuse, keep recycling streams clean, and treat concrete as both essential and a carbon challenge, specifying lower carbon mixes and holding projects to high performance. Linked to the SDGs, these are not slogans but measurable choices. Fewer exposures, less plastic leakage, and lower embodied and operational carbon. The Anthropocene will record what we do next. Let's make our signature stewardship tighter cycles, smarter materials, and a shrinking footprint that proves campuses can lead in both ideas and evidence. Yukon is ready. Let's write the better layer together.